Hello everyone and welcome back, and thank you so much for the love and support that you gave me on the first episode of facial recognition in Python. And as I promised you before that, I'll be bringing the second part where I'll be doing a small POC, and I hope you enjoyed the Call of Duty cut-off trailer. And if there are any fans of Call of Duty, please hit the like button. So today we're going to learn about facial recognition and how we are going to implement it with a video file or a video. And today we'll understand the code and what the methods and functionalities that we have in the code that actually brings out the facial recognition on the videos. But having said that, what I would say is code is available everywhere. So what we are going to do today is we are going to understand what the process is, and we'll learn what the functions and methods actually do. Okay, then I'll give you the code. You can practice it on your own, but having the knowledge of what the functions and methods actually do is the main goal that I'll be having today. So consider this as a first step of your facial recognition tutorials so that you can go ahead and learn about deep learning and neural networks. So I'll keep it as simple as possible for everyone who is watching this and is new and wants to learn about facial recognition. They can get some idea so that they will get a kickstart on their journey towards facial recognition and deep learning and as well neural networks. So if you're ready, let's begin. Okay, so let's start understanding the process. So the first thing that we need is the video input file. Here I'm using the cut down version of the trailer of Call of Duty Modern Warfare. And this is what we will use as our sample based on which we will test the facial recognition using face recognition and OpenCV modules of Python. If you use a video, it is for sure that you know the names of the characters and the person in the video that you're seeing right now. But our system or algorithm, which works on deep learning and neural networks, and of course it is very smart, but the system or the code or the algorithm doesn't know the name of the faces, isn't it? So that is what our second step is. So what we do is we take the screenshots of the characters we want our algorithms or code to be familiar with. So I have taken the screenshot of the characters that we wanted to take. So if you have played Call of Duty Modern Warfare already, then you already know the names of the characters. So I'll introduce them one by one anyways. So this is Alex and this is Station Chief Kate Laxwell. We have the bad guy here. This is the villain that we have. And she is the protagonist of the game, you can say, Farah. And this is our favorite Captain Price. So the third step is to feed these images to the facial recognition algorithm, which uses dlib to encode these images. And using the dlib facial recognition network, we generate the output feature vector. That is a list of 128 real valued numbers that will be used to quantify the face, or in simple words, these points collectively will be used to recognize and differentiate one face with the other. And these 128 points that you see here, these are a collection of 128 real value numbers, and these 128 points will also help us in determining a face in the different scenes based on the tolerance level. So if you get multiple face matches for the same person, it might be that the people in your photos look very similar, and a very low tolerance value is needed to make face comparisons more strict. So the default value of fault tolerance is 0.6, and the lower you go, the stricter it gets. But it will be that slow as well to process. So you must understand that when we use facial recognition and we feed an image to it, so it converts it and encodes it into 128 real valued numbers. Okay, so this face that you see is a combination of 128 real valued numbers, and this is the facial encoding that we get once we use face recognition module in Python. And the third step is to feed these images to the facial recognition algorithm, which uses dlib to encode these images, as I already said. Okay, I'm saying this as a third step because I have already explained the second step before, but it was encoding part 1. So I wanted to elaborate it more in depth so that you can get the whole gist of it. And so getting into the topic once again, and using the dlib facial recognition network, we generate the output feature vector, that is the list of 128 real valued numbers. These numbers Okay, and these 128 real valued numbers will be used to quantify the face, or in simple words, these points collectively will be used to recognize and differentiate one face with the other one. Okay, and these 128 points will also help us in determining a face in the different scenes based on tolerance value. So if you're getting multiple matches for the same person, it might be that people in your photos look very similar, and a lower tolerance value is needed to make face comparisons more effective or more strict. Okay, as I already told you, the default fault tolerance is 0.6, and the lower you go, the stricter it gets, but it will also affect the performance and it will be slower as well. So here you can see two images of Captain Price, but based on the posture, the face angle, the expression of the face, the encoding algorithm will generate facial points and compare it with the reference encoding values. So let's suppose this is the reference encoding value that I have. So when you generate the facial recognition encoded value for this type of face, it will compare both of them. And based on the tolerance value that we have as an input in the encode step 1, it will compare it with the reference encoding values which we have provided as an input. So having said that, we are very fortunate that we are living in an age where the games we have right now are so close to real life. Now we have some idea of how these things work. Let's put these things together and check the workflow. So I hope you understood what we are going to do here. So we take the screenshot of the videos that we want, where we have the faces already captured, and then we feed it to the facial recognition algorithm, which generates 128 real valued number encoding values. And based on this particular value, in every scene that you see, it will compare this encoded value to that, so that if anyone actually matches with that, then it will tell that yeah, these two faces are similar. Okay, so let's check the workflow. So yes, there comes actually the interesting part. So here what happens is, using OpenCV and Python, we render the input video file with video capture, and then we read and generate each and every frame until there are no frames left. Okay, so this video file, so every video file that you see here will be consisting of number of frames. Okay, so when OpenCV actually reads this file, it converts it into multiple frames. Okay, and it will keep on reading them until and unless there are no frames left. But with OpenCV video capture read, you generate one frame per loop. So the cycle that you will see is a representation of a single loop. Just for example, I have shown a bunch of frames, but actually in real time, what happens is it actually generates one frame at a time. And for each frame that we generate using OpenCV, we repeat the encoding process using face recognition to generate the facial points. Okay, and then we take this encoded frame and compare it with the encoded frame that we have generated in the step 1 based on the desired tolerance value. So tolerance value I have given like 0.50, and if there is a match, then we create a frame and a name text so that we can show that as a part of the frame itself. So as you can see, it found a match. So what it did, it tried to portray it with a rectangle or a square with the green color that you see here, and it wrote the name. Okay. And this happens dynamically and it runs throughout the video. Every character that you add will go through the same cycle. And this will keep on repeating until there are no frames left. So what we do is we take the video, we convert that into frames using OpenCV, and then we feed each frame to the face recognition algorithm, where it converts it into 128 real valued numbers. That is the encoding step that we have. And then with the reference encoding step that we already had created before, it compares both the values based on the tolerance value. Then if there is a match, it generates the frame. Okay. And that is why you see the square boxes here. Once it generates, it tells us that yes, we have found a match. Okay, so I hope that was clear. Let's move on. So this is our input file. Okay, so this is the input file that we used. Now let's see the output file. That was awesome, isn't it? But the main thing is to understand what actually happens with the code. Okay, so let's check the code. Okay, so this is the code that we are going to use for our facial recognition, and this is a pretty simple code that I'm going to explain you, but there are a few things that you need to understand, and there are a few prerequisites that you need to first of all incorporate in your code or in your interpreter so that you can make use of this code. Okay, the first thing that you see here is import OS. Everyone knows that import OS is basically by default it comes with Python, but this one, the import CV2, actually we need to install it. Okay, so in our terminal, as if you have seen the previous videos that we already had, so in the terminal, if I go back once again, and this is the virtual environment that I created in the first episode. I hope you all have seen this. So I had installed the facial recognition module here, and if I do a pip freeze again, okay, so the only thing that I have added recently to use this facial recognition code is basically this one, OpenCV Python, and you can install this, okay, by typing pip install opencv-python, okay, like this, pip install opencv-python, okay, like this. So once you've installed it, you will see this in your pip freeze output, and you're good to go. You can use it. Okay, but as you can see, I am having my virtual environment running in the terminal, but I am using Visual Studio Code here. So how are you going to import your virtual environment? Okay, so the best thing that you can do here is hit Ctrl+Shift+P, and you have to type here interpreter. Okay, so once you select interpreter here, this option will come like Python select interpreter. Once you click on this one, you have multiple options that you get, but you have to go to enter interpreter path. Once you click on this, you will get the find option where you can browse for your file system to find the Python interpreter. So just click on this and it will open up the dialog that you have, dialog box or the browser window. So here you can iterate it to the folder where you have the virtual environment. So that was on my desktop, my venv.py or my venv.py. Inside that I have scripts, and you have to just click on Python and you have to select the interpreter. You have to select Python and you have to select the interpreter. Okay, so once I've selected this, my interpreter is set, and I can right click on this one and run the Python file in terminal as well. Okay, that's the biggest advantage that we have. We can have our custom virtual environments also incorporated in Visual Studio. Okay, so that's the first thing. And the second thing that we have here is import face recognition, or that's the third thing. This we have already installed before, and I would recommend you watching the first part of this video series so you can have a better understanding of how we actually installed it. And for those who have already installed it, well and good, you are in the right place right now. So the first thing that we have to do, we have to import our video file. So what you can do is you can create a videos folder here, and inside that I have placed my Call of Duty trailer.mp4 file, and that is what I'm going to import in my code as well. So CV2 is the module that we are going to use. It has a method called video capture, which takes the path of the video file. Okay, so I've given the path, absolute path for the video file here. So this basically helps us to import the video file that we want to use. Okay, and then we have to find the length of the frames that we have. So using this video file .get, there is a cv2.cap property frame count. So what it will do is it will count all the frames that you have in the video, and I want to use it as a part of my length variable. So what it does is it checks the video file or trailer1.mp4 and it counts all the frames that it has. So every single frame that you see on your video file will be counted. Okay, and the next thing that we are going to do is I'm going to, as I told you, that we need our faces to be recognized, isn't it? And I want to name those faces. So how will I name them? Or I have to tell the facial recognition algorithm that these are the faces that I want. So I have named all the faces that I want, like Alex, Bad Guy, Farah, Laswell and Price, and I've taken screenshot of all these characters. Okay, and I have placed them in images folder. So this, so like this, I have placed all the images of the people that I want to be recognized by my algorithm. Okay, so you can also do this. So I'm just giving an example. You can try it with your own videos, and you can take the screenshot of your own face and put it here, and you can feed it to the algorithm. So once you have taken all these screenshots, you can place them in the images folder, and there is a facial recognition load image file method that you can use, and it takes the path of the JPG or PNG file and it actually converts them into NumPy arrays. Okay, so each file that you see will be converted into NumPy arrays. After you have done this for all the images that you want to be recognized, you have to generate the face encoding using the facial recognition dot face encoding method. Okay, so what it does, given an image, it returns the 128 dimension face encoding for each face in the image. So if you want to see how it looks like, so these are the facial points and this is the face encoding. These are the 128 value dimensions face encoding values. Okay, so moving on to the next step. So once you have generated all the encoding values, you now know that if there is a match for these encodings in any of the frames for the video that you have, this video that you have, we will get the boxes in that, but we have to create the boxes, so that will be there. So keep watching. So these are the known faces list that I have created, and in that I have put all the values that I have for the encoded faces. So Alex face 1, bad guy face 1, Farah face 1, all these I have put them in the list. Okay, we have the step ready where we have all the encoded faces in the list. Okay, so the next thing that I'm going to do is I'm going to loop over all the frames that I'm going to generate. So while true in the sense while there are frames left on the video or the video read that we are going to do, I'm going to iterate over all the frames. Okay, so here what we are doing is we have this video file and the read method that you see here will read each and every frame one by one. Okay, and if the return value that you see here is true, it will return the frame as well. Okay, so if we see here the read module or the method that we have grabs, decodes and returns the next video frame. Okay, and every time you keep on calling read, it will generate one more new frames. Okay, so the image, the video frame is returned here. If no frames have been grabbed, the image will be empty, and it returns false if no frames has been grabbed. Okay, so the method or function combines video capture grab and video capture retrieve in one call. This is the most convenient method for reading video files or capturing data from decode and returns the just grabbed frame. Okay, we don't have to dig deep into what this actually does. So what it actually does is it basically reads the file, the video file that we have here, and this uses OpenCV. Okay, so with OpenCV we will be reading the video file frame by frame. So here we get the return value as true and this is the frame. Okay, so every frame that you see here on the video will be counted as a single frame that you are going to get it from the read. And after that, what happens if there are no frames left? I have added a condition here, if not return value, then it will break the loop. And here this is the RGB frame that I'm calculating from the frame value that I get. So if you want to see how the RGB frame actually looks like, so the frame actually looks like this. It is a NumPy array, and from there I am trying to exfoliate or I am trying to index the RGB frames. Okay, so you can read about these things on the documentation as well on how it actually extracts it. So the next thing that we have here will generate the facial points for the face that we have. And if you see the face recognition method here, face location, it returns an array of bounding boxes of human faces in the image. Okay, so every face that the image finds, it will return the bounding boxes, the array of bounding boxes in that. Okay, so the parameter it takes is an image as a NumPy array. So this is basically the NumPy array that it takes as an input. And the one thing that is very important for you to remember is, you might ask, why am I using model CNN? So here what happens, we have two types of models. The first one is HOG, which is basically less accurate, but it is faster on the CPUs, and CNN is basically, it is much more accurate. You can read more about this. And a deep learning model actually uses your GPU. Okay, if that is available, it will use that, and the default value is HOG. So by default it uses HOG. If you supply or if you pass CNN as a parameter for the model, it will take model. Okay, and this will be much more accurate than HOG, but it will be very slow. Okay, for me it actually took around 3 to 4 hours to basically generate based on my speed or my PC speed or my laptop speed. Okay, but if suppose you're using a very good computer, then it will be faster for you. So the next thing that we're going to do is we are going to generate the face encoding for the frames that we have derived from the video file. Okay, from the file that we have derived the frame, from this RGB frame, we will be deriving the face encoding values. Okay, the first one we did it here. Okay, And here we are doing it for the RGB frame itself. Okay, and with using the facial point. So in that facial point or the box, actually it will try to encode the face so that it can find multiple dimensions of the particular face that we are going to see. And once you have got the face encoding, then you have to loop over the face encoding values that you have, and then for each encoding that you get, you're going to compare it with the known faces. Okay, so facial recognition has a compare faces module that I told you before. So it takes the known face encoding, the face encoding to check, and the tolerance value. By default it is 0.6 as I told you, but I'm using 0.5. Okay, so it will be a bit accurate, but it will be slower as well. So the parameters that we pass is known face encoding. It is a list of known face encodings, and parameter face encoding to check is a single face encoding to compare with the list of parameters that we pass. Okay, and the param tolerance that you have, so how much distance between faces to consider it as a match. Okay, so lower is more strict, 0.6 is the typical best performance, and it returns a list of true or values indicating which known face encoding matches the face encoding to check. What it actually does is it takes the known faces list that we have generated, okay, and compares each encoded value with the encoding that you pass, okay, from the face encoding for the frames that we have generated. Okay, and it tries to compare each of the values. So if suppose the image has, let's suppose 5 faces, okay, so it has to generate images or the image frames for 5 faces. Okay, if it detects based on the known faces that you have supplied, then what it does, based on the encoding that you provide, it will generate 5 boxes on that particular image. Okay, if it matches, on the condition that it matches all the images. If suppose it matches only 3, it will generate the boxes for only 3. Okay, and then what it does, it returns the matches. Okay, so as you can see here, we have false, true, true, false, false. I have taken an example for a sample frame. So here what happens is false, true, true, false, false denotes the way I have passed the list. Okay, so let's suppose I want to map these 5 values. So if suppose I take these values and I keep it here for your convenience. Okay, so I want to match that whether these faces were recognized or not. So what this match list tells us, false in the sense it will compare it with the first index, second will compare it with the second index, here the third value will be compared to this third index, and true, true denotes that these faces were found. And the same way, what I'm trying to do is, if I'm checking whether match of 0 is true, then I'm naming it as Alex. Okay, based on the list I have passed. And then if suppose the match value is 1, then I'm passing it as bad guy. Similarly, for every encoding that it does, I am actually trying to match it with the value that I'm getting in the output. Based on what the names that I get, I actually append them in the list. So the next thing, I iterate over the loop of the zip that I create from the facial points. The facial points is basically like this, like this. Okay, this is the coordinates of the facial points. This is basically the box actually that gets generated, and the names and the names, facial names. Okay, so let's suppose there are 3 names that get generated. I map each of them. Okay, and then I iterate them and I create the rectangle. So cv2.rectangle, what it does, it takes the image, the frame that we have, the left top and right bottom, and the color that I am going to choose as red, and the thickness of the particular box. So after you've created the rectangle, you obviously want to name the character that you have got. So for every frame that you see, we create a small rectangle below, okay, which is also of red color, and we have filled it. And also the next step that we do is we add a font. So cv2.font Hershey duplex, that is the font that I'm currently using, and we put the text on the frame on that particular coordinates that we have. So this basically has generated your name, and here you have generated the box. Okay, and here you have generated the text. So this looks like something like this. So then what I do is I introduce a codec, and I take every frame that I have and I filter all the frame property width and the height based on what I want to create the output file, and I write the output file in a video writer. I give the name as output underscore the frame name that I have, the facial number that I have, and for each frame it generates the output.mp4 file based on the codec, FPS value, and the frame width and frame height. So once I have written that, I write it down to the video file. So once it is done, for every output file that I generate, I write the frame into that particular file. Okay. So let's suppose it generates output underscore 1. So that particular frame will be written into that particular video file. So once all these frames have been generated and encoded and have been generated as a part of the frame and have been put in the output file, I'll release the video file, I'll release the output movie file, and I'll destroy all the windows. So if I run this, it'll take a lot of time. So for this codec to actually work, you need a open H264 codec file, which is basically a DLL file, and you need to put it exactly under the repository that you have, inside the repository that you have, and along with the py file that you're currently generating the output for. Okay, otherwise it will give you the codec error and your output will not be generated. This output.mp4 file will not get the frame. Okay, so this OpenH264 codec is really important and you need to download it and you need to put it here. So once everything is done, you can either clone the repository link that I have given, and you can right click on this by opening it in an IDE that you want, and you can just run the Python file and it will generate a sequence of all the frames that are there in that particular video file. Okay, so for this one, I had nearly about 172 video files. So these are all the video files that got generated based on the output that I was trying to fetch. 172 files, it got generated. For every frame that you see here, it will generate the output. Okay, and this is the way that actually it generates the boxes and it writes the name on the frame. Okay, and then we can see the side-by-side comparison as well. That will be really interesting, isn't it? Let's see. So now that we have learned how the code actually works, so you would want to actually run this, isn't it? So I'll give you the code in the description below. I'll give you the Bitbucket URL or the GitHub URL. So there you can go ahead and download or clone the repository that I have. So I'll tell you exactly how to do that also. Okay. So you have to go to the browser and you have to type the URL that I have put here. So https github.com/pytholic/codeface-recog. So this is basically the repository name that I have. So this is the package, recognized package that I have. So you need to just click on this one and you will find the source code. And if you click on the face engine video.py file, you will find the source code here. Okay. So this is what you need to run. Everything has been committed. This is the master branch that I'm currently using. And you can also use this one. So what you need to do is you have to go to the repository folder and you see the code here, right? Code option. The code option here. So what you need to do, you need to just click on this one and copy the link. Okay, copy the link here, https github.com/pytholic. This link, once you copy it, okay, or as well you can open it in GitHub desktop or you can download the zip file as well, but I'll show you how to do it with the GitHub or Git bash. So you need to just copy this, and if you have git bash, you can just open this git bash from your command prompt or the prompt that you have here. So this is the application that I'm going to use now. So once you have got this, if you do a ls, you will find every place that you need to go or iterate from your desktop. I'll go to the desktop here and I'll do a ls. I have all these folder structures here. Now what I have to do is I have to just create a folder. So to create a folder, I'll just type mkdir and I will type source. Once you have typed this command, then you can just hit enter. So now it would have created a folder for us. Yeah, see, it has already created us. So once you have created the folder, what you need to do is you need to just type git clone space. You need to copy this and you have to just paste it here. Okay. And it will clone the repository for you. Okay, so now you have cloned the repository. You can do a ls and go inside the folder structure that we have. Cd recognize ls. Okay, so this is the file that we want to run, but we can't run it just like that, because if I type Python, so this will actually fail for you because you haven't logged into or you haven't activated your virtual environment. So what I'm going to do, I'm going to go to the terminal that I have, and I'm going to iterate to the path where I have the virtual environment. So cd desktop, I have it on my desktop. You can go to the place that you have your virtual environment in. So face recog, cd face recog, cd my env, and inside this you will find the scripts folder, and if you do a ls, you have this activate. There's the one that we are going to /activate. Okay, so now my virtual environment has been activated. Okay, so you can do a pip freeze. Once you have done this, you can see all the modules that we need to run this code. So now what we have to do is we have to just iterate to the path where we have the code. And if you don't have opencv python, you have to just type pip install opencv-python, and you have to just hit enter. If I just hit enter now, it will say that I have already installed it. The same way you can install it for yourself, and I'll just come out of the directory structure that I have, and I will go to the source code that I already have created. Cd source, I'll do ls, cd code recog ls, and cd recognize, and I'll do ls in this one, and this is the file that I want to execute. Okay, so what I will do, I'll just type python space faceengine.py. okay, that's it, and hit enter. And if you find this type of problem, what exactly I have mentioned in the code is I have written absolute path from recognize. So what you need to do is you need to just do cd ... and you have to come out, and being in the parent folder itself, you have to type python, or you have to type recognize, and you have to type the file name. Okay, as you can see here, it is telling open H264 video codec provided by Cisco Systems Incorporation, and it is writing one frame out of 172. So there are total 172 frames in the input video file that I had provided, and it has started writing the frame 1. So similarly, it will write all the frames that we have, 172 out of 172, and it is going to take a lot of time, so I'm not going to do this right now. I'll just show you like all the frames that it gets generated once this is completed. These are all the files it gets generated with my input file. It will be same for you based on your input file that you have provided. So I hope you got to know like how you can run this file. This repository link will be available in the description below. You can use it, and you can iterate to the files that we already have, and this file is already present in the repository itself, so you don't need to download it specifically for this one. It's already there for you to use. Go ahead, use it, enjoy with this. So that's it. I hope you enjoyed the session here. It was really interesting for me to work on this one. It was a very small POC, but I hope you got the gist of how it actually works. And now you can go ahead, and I would have provided the Bitbucket link of the source code that I have. So go ahead, it's free, download it, follow the process that we have followed, install the facial recognition module using the first video that we had, and come back to the second video and learn how facial recognition worked and how we were able to actually do this. Okay, so I would want you to actually do this real time on your laptop or your system that you're working on, and please do send me your feedback on how it actually worked for you and did you enjoy it or not. Enjoyment is really important. Okay, so this was a lot of fun for me as well to have this interaction with you guys, and thanks a lot for all the support and love that you have given me on the first video. Make sure you check out this one as well, and make sure you hit the like button, and if you did like it, then please comment on what you liked, and please do keep supporting me like this so that I can bring more videos for you guys. And I would ask you like what next you would want to see, or what is the next thing that you want to see from my side, and if you can just put them on the comment section below, then I'll be really happy. And please do subscribe to the channel if you haven't already, because we are going to bring in so many new topics. And if you are interested in AWS, I have already got a series running on the channel. You can go and check out that as well. So until then, stay safe, stay healthy. It's Pythoholic signing off.